Hello all the chemistry students! Here are some of the things that we are going to discuss about this structure. This structure is the largest structure that we have been learning in the class. The structure that we're gonna discuss today is Spinel. Before going through about this structure, let's look how the structure looks like. It's great, right? Let's talk about this structure. This spinel have chemical formula MgAl2O4, which is called magnesium aluminate. It is also made of 8 face center cubic. Anion in this spinel, which is O2-, occupy the FCC lattice. Magnesium cation occupy 1/8 tetrahedral hole, while aluminum 3+ occupy the 1/2 of octahedral hole. But what gonna be coordination number for this structure? In coordination number, we know that in one FCC lattice unit cell, the effective number of atoms occupying the lattice points is 4. At the same time, the effective number of tetrahedral hole is 8, and that of octahedral hole is 4. Let's calculate it together. In normal spinel, the number of anions, which is oxygen 2-, occupying the lattice point of 8 FCC unit cell. So, 8 will be multiple with a 4 and will be equal to 32. Whereas, the number of magnesium 3+ cation occupy 1/8 of tetrahedral holes. So, it will be 8 multiple to the 1/8 and 8. So, it will become 8. And for the aluminium 3+ ions occupying the half of the octahedral hole, and it will be 8 multiple to the half and 4. Then it will be equal to the 16. As a result, the ratio of Mg2+, aluminium 3+, and O2- is 8, 16, and 32. After simplified it will be 1, 2, and 4, which confirms with the formula of MgAl2O4.
Next, let us calculate the unit formula for a spinel. For aluminium cation, 8 edges times 2 for top and bottom times quarter times half equal to 2. Next, 8 edges times quarter times half is equal to 1. Then, 4 faces on top of big FCC times 6 sides times half times 1/2 is equal to 6. Then 2 times 3 edges for XY axis, XZ axis, and YZ axis times 1 times half is equal to 3. Lastly, 1 center of FCC times 8 times 1 times half is equal to 4. So, total for Z aluminium cation is 16. For oxide anion, 8 corners times 1/8 plus 6 faces times half plus 12 edges times 1/4 plus 4 faces times 6 sides times half plus 1 center inside big FCC times 1 plus 4 times 3 XY, XZ, and also YZ axis. This sum up is equal to 32. For magnesium cation, 2 center times 1 times 4 unit cell is equal to 8.
But, is there any application for this spinel?
Of course it have. So, the first application is metal-ion batteries.
For metal-ion batteries, Spinel structure manganese oxide have demonstrated to be most promising positive electrode materials for large-size batteries for EV and industrial application, as they are cheaper, less toxic, and show higher safety.
The second one is laser devices.
In laser devices, Spinel allows the generation of short nanosecond pulses with peak power near an eye-safe wavelength of 1.5 micrometer, making it ideal for telemetry applications. Cobaltous cation, the magnesium aluminate has a wide absorption spectrum in the wavelength range of 1200 into 1600 nanometer, indicating that cobalt ions replace that tetrahedral coordination of magnesium ions in the lattice of magnesium aluminate.
And the last application for Spinel is supercapacitors.
Thank you for listening.